sometimes when we're working with law of sines, we're given a case that's ambiguous. We're given two sides and an angle that's not in between those two sides. And so really what I have, if I think back to some geometry stuff, is I have a case of SSA, two sides and an angle, which was not one of our triangle congruency proofs from way back when. So that's what makes this ambiguous. What might be true is I might have a normal triangle, I might have two triangles, or in fact I might not have any triangles that are formed. And so my question this time is to figure out how many triangles are made and then solve those triangles if I have anything. So what I've done was I've started to draw what this triangle could look like. So I've labeled angle A down here as 51 degrees. I've also labeled this as side B, and what I'll need to do is compare how this the second side, this 3.5, this A side, compares to this straight perpendicular line if I were to drop that right down there. So that it's all going to depend on how long that missing imaginary side is. I'm going to call that side H, and to find it, that's equal to B times the sine of angle A. And that's just coming from some basic, simple trigonometry, some SOHCAHTOA stuff. So let's go ahead and find out what side H would be, compare it to the side that I have, and then figure out how many triangles are formed. So in this case, I'm going to do H equals side B, which was 5, times the sine of angle A, which is 51 degrees. And using a calculator and making sure that I'm in degree mode, I find out that side H is 3.89 units long. So if I were to drop a side straight down from the top of that that triangle straight down, it would have to be 3.89. Well, taking a look at what I have, that missing side that I need to draw in, side A, is only 3.5 units long. It's not quite long enough to reach the bottom. If I were to drop that straight down, it would get maybe to about there, meaning I don't have a triangle formed. There's this gap right here. So because side A was shorter than that side right there, side A, was less than side H, there's actually no triangles that are formed given these numbers, and so there's no triangle to solve for. There's been no triangle that's formed. So in this case, this ambiguous case, when I had two sides and an angle, because side A was less than that missing side H if I were to drop it straight down, there was no triangle formed, and I just stopped the problem at that point.